Hey A&Pers, this is Dr. Jones checking in. This is A&P 1, Lecture Test 5, Video 16, covering page 17, more on the synapse. There are, let's see, we talked about synapses. Okay, let's talk about cholinergic synapses. So a cholinergic synapse uses the neurotransmitter acetylcholine. Get it? Choline, cholinergic. So that's A, capital C, lowercase h. So here we have a cholinergic synapse, because that's as small as it gets. All right. So locations of cholinergic synapses. Number 1, all neuromuscular junctions with skeletal muscle fibers. We've already learned about that one. 2, many of the CNS synapses, many synapses inside the central nervous system, which as you know is the brain and spinal cord. 3, all neuron-to-neuron synapses in the peripheral nervous system. And we've had this conversation. I'll just draw it on here. I need a pen. Pen color red. Okay, we've had this conversation where we drew the CNS and then the peripheral nervous system. And we had the motor neuron that landed at a skeletal muscle. And then, so that's the SNS. And then in the ANS, we had 2 neuron system for both the sympathetic system and the parasympathetic system. And we had a preganglionic cell that synapsed in an autonomic ganglion, the AG, with a ganglionic neuron or cell, and that synapsed with the visceral effectors. So this is the what effector? I'm having a massive brain fart, I don't remember. So here we have the visceral effectors, which are smooth muscle, cardiac muscle, glands, and adipose. Visceral effectors, somatic effectors, there we go. Somatic effectors, skeletal muscle, I remember. All right, so what we just said for cholinergic neurons, let's make the acetylcholine cyan, because that's a fabulous color. All right, so we had number 1, all neuromuscular junctions. So this is cholinergic. We said many synapses inside the CNS. So many of the things inside the CNS are cholinergic, but not all. All neuron-to-neuron synapses in the peripheral nervous system. So these are all cholinergic, using acetylcholine, whether it's sympathetic or parasympathetic, the preganglionic cell uses acetylcholine. And then all neuromuscular and neuroglandular junctions in the parasympathetic division of the ANS. So parasympathetic is acetylcholine equals. That doesn't look like a parasympathetic and an equals. Okay. Parasympathetic here uses acetylcholine. The sympathetic, what color? Ooh, green's kind of vivid. Sympathetic does not use acetylcholine at the neuroglandular or neuromuscular or neuroglandular junction with the visceral effector. Sympathetic uses epinephrine or norepinephrine. Epinephrine is adrenaline, and norepinephrine is noradrenaline. And so epinephrine and norepinephrine are abbreviated capital E. Norepinephrine is abbreviated capital N, capital E. So east by northeast is epinephrine and norepinephrine. And so these synapses in the sympathetic system use epinephrine and norepinephrine, but parasympathetic, oh, that got too colorful. That just got way too colorful. I think that hurts my eyeballs. So the fourth place where we find cholinergic synapses is at the visceral effector junction of the parasympathetic system. So the neuroglandular junctions and the neuromuscular junctions in the parasympathetic division. Okay, so what happens at a cholinergic synapse? And now I suddenly need this picture that I have drawn all over. So you get how that works. Kind of wanted to keep it, but I kind of need this space too. Got it. Okay. So the events at a cholinergic synapse. Number one, we need to get away from the eraser. Did I do it? Okay. So these red zappies here are the action potential that arrives and depolarizes the synaptic knob. The synaptic terminal, also called an axon terminal, all means the same thing. Number two, this is the part that used to be covered with neuromuscular junctions, but then they deleted it out the book, and I think it's still on the review page. So this, in the synaptic knob, you have voltage-gated calcium ion channels. I know. Yeah. So the action potential at the synaptic knob, oh, and also calcium goes into the cell when you increase calcium permeabilities, allows calcium into the synaptic knob. And the number three, no? Okay, still in number two. The influx of calcium ions into the synaptic knob causes the exocytosis of acetylcholine. I don't know how. I know that a few years ago, a couple of people got a Nobel Prize for working out how the influx of calcium causes the exocytosis of the acetylcholine, and I have not yet read that paper. But I'm okay with the influx of calcium causes the exocytosis of the acetylcholine. Without quite knowing how. So feel free, if you want to know, to look that up and read maybe just the synopsis, but write your extra credit essay on exactly how does an influx of calcium cause the exocytosis of the neurotransmitter from the synaptic vesicles into the synaptic cleft. Might be fun. Okay, so that's two. Change our slide and talk about number three. Number three, the acetylcholine binds to the acetylcholine receptors on the postsynaptic membrane. And that depolarizes the postsynaptic membrane, assuming we're talking about chemically gated sodium ion channels. And this causes a graded potential in the postsynaptic cell. If it causes threshold in the initial segment of an axon, then it can cause an action potential. Either way, it always causes a graded potential, but might also cause an action potential if the graded potential is big enough and in the right spot. So we'll talk about that. And number four, the acetylcholine is broken down by acetylcholinesterase, capital A, capital C, lowercase h, capital E, ACHE, all caps but the H is lowercase. and it snaps it into its two constituent parts, which are acetate and choline. Now you do need to know that the choline is reabsorbed by the synaptic knob and used to, and it's recycled to build more acetylcholine. The acetate, however, diffuses off out of the synaptic cleft to be used elsewhere. Okay. I think I have told you everything that I have written down here, except in number 2, I have also written down that the book says there are roughly 3,000 molecules of acetylcholine in each synaptic vesicle. Just to give you a concept of the scale that we're talking about, there's like a lot. Okay, so the synaptic delay is 0.2 to 0.5 milliseconds. Every time you have a synapse, you have to wait to release the chemical, for the chemical to bind, and then the ion to enter the second cell or leave the second cell, depending. And so the synaptic activity takes time, but it gives you a chance to inhibit or facilitate, and I've used those words too soon because I have not defined those yet. Okay, scratch that last bit. We'll come back to that after we find those words in the note set and we've defined them. So now, the importance of reflexes. Reflexes have fewer synapses, and therefore you're able to respond more quickly because there's less synaptic delay involved. Some reflexes are monosynaptic, where there's only one synapse. There's a sensory neuron that synapses with a motor neuron, and there aren't a lot of them, but there are some, where there's an instant response when you need it. And then some have very few synapses, but more than one, so they're polysynaptic. Like hand on a hot stove. If your hand is on a hot stove, your hand is reflectively removed from the hot stove about the time that your brain finds out, because there's a reflex arc that uses fewer synapses and therefore has less synaptic delay. Next question, synaptic fatigue is when you run out of neurotransmitter and you can no longer keep sending that message. All right, so that, and 12.7, we're not talking about all of the different neurotransmitters. There are a few neurotransmitters that commonly get talked about in the news, like dopamine and serotonin and that kind of thing. We're talking about acetylcholine and epinephrine and norepinephrine. So. All right, that is it for this video. This has been ANP1 Lecture Test 5, Video 16, covering page 17. Thank you, as always, for tuning in. It's good to virtually see you here. You are doing great. And you know how I know that? Because you're still here, and you're still watching the videos, and you're still learning. And that takes grit. And you've got it. So keep on, keep it on. Dr. J out.